All right, this is, remember that there's 3 theorems in this section to find the segment lengths inside or outside the triangle. There's the chords, right, where we multiply them together. There's the tangent and a secant, which is tangent squared equals whole times external. And then there's the 2 secants, which is whole times external equals whole times external. So this is the chord scenario in which we have to multiply, and it would be x times 20 would equal 4 times 10. 20x would equal 40, and x would equal 2. We good on that one? Yeah? Okay, chord again. This time it's x times x plus 1 equals 4 times 18. So I get x squared plus x equals, and then I have to multiply this out, 18 times 4, 72. Good. Now this is a skill you needed from Algebra 1. I'll review factoring with you a little bit, but this is a skill you needed from Algebra 1. As soon as you see the squared and the x, you got to get everything to one side, and you're going to have to factor it. I keep my x squareds positive always. You don't have to do it that way, but to me it's the easiest. So I move the 72 on the side with the other 2. So this becomes x squared plus x minus 72 equals 0. And then I'm going to factor. So I'm looking for the factors of x squared, which are x and x, and the factors of negative 72. So that add to positive 1. Good. I need factors of 72, right? So we know them now, but if I didn't know them, I would work through until I found the one, right, which is going to be 8 and 9 that are 1 apart. So this is positive 8, or positive 9, sorry, and negative 8. You're going to have, well, this is factoring. This is in quadratic. You are going to have to factor. So we'll review a little bit more, and I'll actually, if you know you have a whole where factoring comes in, I have a video that goes through all the different kinds of factoring. It's a good refresher. I'll put it right on the module. Okay? So this is negative 9 and 8. Can a segment length be negative? No. So I get rid of the negative 9 and I keep the 8. So again, if factoring is what's getting you, I'll put a video right on there that goes through all the different kinds of factoring that you should have known up till now, but at least it hopefully we'll review. And then we'll do a couple more review with the factoring before your test. But you definitely are going to see it. It was negative. All right, this is a tangent and a secant. So the rule is tangent squared equals whole times external. Whole here would be 25. External is 9. Tangent's x. So x squared equals 25 times 9. And then I'm going to have to square root both sides. So listen, we could multiply out 25 and 9, but remember, we're going to have to square root it anyways. So you might as well just square root and square root, and it's 15. Good on that one? Okay, now we've got 2 secants. So it is whole times external equals whole times external. Whole here is 40 times the external part is x. Whole here is 45 times the external part, which is 18. I haven't worked it out yet, but possibly. Oh, and it says to round to nearest tenth, right? What'd you get for 45 times 18? So what's 45 times 18? 810 divided by 40. Or 20 and a fourth.
That's what.
Okay. So, but it said round to nearest tenth, so technically it would have been 20.3. Good. Yeah.
If you like using fractions more, would you get points off? Would you give us points off on the test if we put it as a fraction?
No, I'd actually it's actually more accurate as the fraction than it is.
I could put 20 and 1/4.
Yeah, it's actually more accurate than if it's rounded. If it was multiple choice, you wouldn't see it. Just realize that. Like this one's not multiple choice, but if it was and it said to round to the nearest tenth, you'd see it that way. But I'd actually the 1/4 is more accurate than the 0.3.
So would you take off points and put it as a decimal?
No, because the direction said nearest tenth. Yeah. All right, and we're back to the chord, right? So this x times x equals 8 times 16. X squared equals 8 times 16. We're going to have to square root, so save yourself the work of multiplying out the 8 and the 16. And now I'm going to break it down. So this is 2 and 4, 2 and 2, 2 and 8, 2 and 4, 2 and 2. And then each pair of 2's, one goes to the outside. Oop. Sorry. Come on. Sorry. This one's left under. And this one said round to the, ooh, it's cut off. Round to the nearest tenth. So if you had a calculator, which I don't think you're going to, but if you did on your test, it would be 11.3. You'd have a calculator and you'd do the square root. Wait, hang on. All right, 10.7 is called writing and graphing equations of circles. So this is, again, a little bit more algebra than geometry. The geometry obviously is the shapes, but we're going to be dealing with equations and then like drawing circles, that kind of stuff when you're on a coordinate grid. So the first thing is that the circle at its origin has the equation that is x squared plus y squared equals r squared. So if my center is at 0, 0, the radius is the length out in each direction. So the radius would be here, 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 or anywhere else where it goes from the center to the edge. And the equation would be x squared plus y squared equals r squared. So if my radius was 3, then my equation would be x squared plus y squared equals 9. That's if the circle's at 0, if the center's at 0, 0.
So do they have to at least give you one x or one y? They have to give you a y?
You mean for... So you're going to see it in a couple of different ways. You'll either see 2 points on there. You'll see the radius and the point, that kind of stuff. So you'll see. If it says it's at the origin, then you know your center 0, 0, and then all you need is the radius. Okay, this one says write the equation of the circle shown. So first of all, center's at 0, 0, right? And from here to here is what? 5. So my radius is 5. And my center's at 0, 0, or at the origin. So my equation is x squared plus y squared equals 5 squared, or x squared plus y squared equals 25. So far, that's it.
So that's only the x squared.
All right, example 2. Says write the equation of the circle with a given center and radius. So now not a picture, but the same information. If it's at 0, 0, it's still x squared, y squared, and then it's equal to the radius squared. So this would be x squared plus y squared equals 4 squared, or 16. This would be x squared plus y squared equals the square root of 5 squared, which is what? 5. This would be x squared plus y squared equals 4 root 3 squared. So the 4 gets squared, that's 16. The 3, good. X squared plus y squared equals 48. Okay, so listen, the top part is just the explanation of where the bottom part comes from. The top part says if the center's HK, which means it's no longer at 0, 0, and I wanted to find the radius length, then I could pick 2 points on this circle and find the distance between them using the distance formula, right? That's what that first thing is. This is the distance formula, x1 minus x2. That's what it would be if you used a point on the circle and the radius. But then if I square both sides of that equation, I get the standard form of a circle if the center is no longer at 0, 0. So all you do is, it's not a big deal, change the sign on the x coordinate, put it behind the x, change the sign on the y coordinate, put it behind the y, and then again set it equal to the r squared. So this is not hard. Don't think that just because that's a complicated equation, it's going to be hard. It's not hard.
I don't get it.
Okay, I'm going to explain it in just a moment if you give me 10 seconds.
So the first equation is where you have to do the distance from there.
This would be if they did not give you the radius and the center. If they did not give you, so the question is what would you use that top one for? And I'm answering it. If they did not give you the radius and the center and they gave you 2 points, then you would plug the points in here to find the radius. If they give you the radius and the center, then you're simply plugging the center in here and the radius you're squaring. That's it. It is super easy.
Wait, so the 2 points, one of them would be like...
One of them would be the center, and then one of them would be on the circle. Yep.
Wait, so what is the first one find again?
That is if they don't give you the radius and the center. And they gave you the center and a point on the circle, so you have to find the radius. All right, so write the equation on the top. X minus h squared plus y minus k squared equals r squared. That's the standard form. So now I'm given the center. This is my h, this is my k, this is my r, right? If I want to plug it in, I do x minus h, so the sign changes, plus y minus k, so the sign changes, equal, listen to what I'm saying, x minus h. H is positive 1. So x minus 1, right, squared, plus y minus 2 squared equals the radius squared, which is 4 squared. So I get x minus 1 squared plus y minus 2 squared equals 16. So when you look at your equation, the signs on your center will always be opposite of what your original points are because we're doing the minus. Does that make sense? Yes? Good. So negative 3 and positive 5 would be x minus a negative 3 squared plus y minus 5 squared equals the square root of 5 squared. What happens with minus a negative? Positive. What happens to the minus? It's going to stay. What happens to the square of the square root of 5? It's just 5.
You just have to find the 2 points that are like on the sensor.
You need the center and the radius. That's all. Yeah. Yeah, which you'll see in some. All right. So 0, negative 2. This is x minus 0 squared plus y minus a negative 2 squared equals 4 square root 3 squared. The 0 goes away, and I get just x squared. The y minus a negative 2 becomes y plus 2 squared. And then this would be 4 squared, which is 16 times 3, again, like we did before, 48. Now I get it in picture form, right? I still need the same 2 pieces of information, which is the center and the radius. What's the center here? 4, 1. What's the radius?
1.
Each unit 1 in each direction, right? Plug it in. X minus h squared plus y minus k squared equals 1 squared, which is 1. Easy stuff, right? Look at B. What's the center? Negative 5, 3. What's the radius? 1, 2, 3. So be careful because sometimes you'll see that little scale change. If that scale says 2, then you know you're going by 2s. Okay, so pay attention because sometimes that changes. So x minus a negative 3 becomes x plus, minus a negative 5. Becomes x plus 5 squared. Y minus 3 squared equals 3 squared, which is 9.